Hey there, math fans. Going to continue our exam 1 topic review. This is going to be about quadratic modeling. As I was making this, I realized I would like to separate the mechanical part from the application part. So let's just go do mechanics first, and then I'll make a part 6b where I do some optimization. Okay, so the thing we learned is that if you're given a parabola, sorry, I'm going to move my screen slightly. If you're given a parabola, it can open upward or downward, whether a is positive or negative. We talked about that. We can find when it's equal to 0 using the quadratic formula. And we can find the x-coordinate of the vertex, whatever that is, using x equals negative b over 2a. So that was our discussion. This video will not be about where those come from. We're just going to use them. All right, so let's read this question. We have Kurt here kicks a soccer ball. This is the function. Kurt's my brother-in-law who passed away, so it's a little bittersweet to do this one, but okay. I used all my family in all these problems. But we have this function. It's going up. I would like the x and y coordinates of the highest point. Okay, so that's a direct vertex question. So we do x equals negative b over 2a. And so we got our calculator ready here. 53 over 4, done. 13.25. So again, that's this x coordinate. Then if we want the y coordinate, we can plug it in and see what we get. There is a formula if you look online, but it's not really any faster than just plugging it in. So that's usually what I do. I like to minimize the amount of formulas I have to remember. Okay. Squared plus 53 times 13.25, 351. If I have anything wrong, please let me know in the comments. That would be fun to spot my error. Okay, you can check the solutions too. There's links to all these. All these come from my practice sheet. Okay, if the ball continues on this path, will it hit the top of this silo? So that question was a little open-ended when I wrote it. There's many ways to do it. You might try it on your own. I remember students being kind of worried about that. You could try to figure out, here's several different approaches. You could say, well, I don't know if it hits or not, but when is it equal to y equals 100? And some students did it that way. So some students figured out, when is this? I remember. I don't know why I remember. I wish I could use my brain for better things. So I don't know, 20 years ago. But I remember students doing this. Problem solving tends to stick with me. And then solving, and then they tried to solve whether the solution to that was between 20 and 25. So that was one approach. So then you can do the quadratic formula, solve. If it's between 20 and 25, you say yes. If it's not, you say no. Some other students were more clever, and they just said, well, I don't even need to solve. I just maybe could plug in 25. So that was clever. They plugged in 25, and they tried to figure out if the height was above or below this, because that would give you some information. So let's try that method. We're going to plug in 25, negative 2 squared, 53, 25. Let's do that. So we're going to do negative 2 times 25 squared plus 53 times 25, 75. Okay, so that means that it actually is down here. It comes down and is down here. That makes me think it does hit, but what about 20? Let's plug in 20 and see. So negative 2, 20, 53 times 20, 260. Whoa. Did I do all that right? 20, we plugged in, we got that. Great. 25, we get this. Sorry to be away from the microphone here. 75. Okay, so that means it must cross. That's kind of a clever way to do it, that it must hit there. Okay, so that's a short way. You could have also solved. Okay, that's the piece we were playing with. Let's do some more mechanical problems. Here's another one from my practice sheet. This is purely mechanical. This was part B of a question. Part A had to do with something else. But it says, assume you have two parabolas here. Find the x and y coordinates of the vertex of F. Oh, that's easy. X is negative B over 2a. A is 1. So A is 1, B is 4. And so you get negative 2. And then you can plug that in to get the corresponding y value. So that's going to be 4 minus 8. It's going to be negative 4. So the x and y coordinates are negative 2, negative 4. And answer the following question. If they both have the same x coordinate, what's the value of b? So then it's having you look over here and say, well, how would I find the x coordinate of the vertex for g? It would be negative b over 2a, so negative b over 20. And the question is, I want that to be the same as the x coordinate of the other one. So b has to be, I guess, 40. Sometimes questions like that with an unknown scare people, but just read it and do what it says. Okay, let's keep going. Suppose f is a quadratic function with the following properties. When you plug in 2, you get negative 5. When you plug in 5, you get 16. The vertex has an x coordinate of 4. When you see something like this that says find a formula for the parabola, write down the general form. This is an overarching theme, which is if you don't know something, label your unknowns. This question is asking you to find what A, B, and C are. And they give us a few conditions. So let's write down the conditions one by one. It says when you plug in 2, you get negative 5. And so this is what you do in a problem like this. I would call this a true modeling problem. So we're going to plug in a 2. So that's going to be 2 squared, or 4. I think I'd write it 4a. We're going to plug in 2 here, so it's going to be 2b plus c. So that's that fact. It gives us one fact. Let's write down the next one. When you plug in a 5, you get a 16. So you get a 16. When you plug in a 5, so that's going to be 25a. How did I get 25? I plugged a 5 here and squared it. And then I'm going to have 5b plus c. And there's a third fact that the vertex has an x-coordinate of 4. That means that negative b over 2a is equal to 4. That in particular means that negative b is equal to 8a, or b is equal to negative 8a. So now I have 3 facts. I should be able to combine them and get an answer. Maybe the easiest thing to do would be to plug in the b, since that substitutes easily. So these are my 3 facts. 1, 2, 3. If you miss the goal, your goal always in solving is to reduce the number of variables. So I'm going to try to go from 3 equations with 3 variables to 2 equations with 2 variables. And I think we can accomplish that quickly by substituting in b. So let's put 1 and 3 together. And I'd have to think about like what's the fastest way. I'm just going to start solving, start combining. So this will become 4a plus 2, and then I'm going to plug in b. And then I'm going to do 2 and 3 together. And that's going to be 16 equals 25a plus 5 times b plus c. And in place of b, I'm plugging in negative 8a. Step 1 accomplished. I went from 3 equations with 3 variables to 2 equations with 2 variables. So now I have negative 5 is equal to, so let's just do this, 4a and negative 16a. So that's going to be negative 12a plus c. And this one's going to be 16 equals, so this is going to be 25 and negative 40. So I think that's negative 15a plus c. So then we went down to 2 equations with 2 variables. Now we want 1 equation with 1 variable. And to me, it looks the easiest to subtract them side by side. So let's do that. Subtract, because the c's will cancel. So this will be negative 21 equals 3a. A has to be negative 7. If a is negative 7, we can then go get b. B has to be 56. If we have a and b, we can go get c from any of the equations. I don't know, maybe, what's the easiest? Here, negative 5 equals negative 12 times negative 7 plus c. So I have negative 5 plus 12 times 7, 79. I did a lot of calculations there, so let me we could do some checking, but maybe it's time we peek. I just did 3 problems. Let's peek and see all the mistakes I made. Let me see here. Sam 1 practice. I don't know if you can see that. Nope. That's right. Just a quick click here. See how I did. In the solutions posted, they wrote it in vector form, but this also takes care of it. Okay, got it. One last one is actually from homework. One question asked for the maximum of this. One question asked for the maximum gap between them. One question asked for the intersect. So at this point, you now should have an idea of what we're going to do. If it's asking for this point, you're going to find the vertex of this. If it's asking for the maximum gap between them, you're going to have to first write down the formula for that. So you need a formula, y equals something. If it's asking for the intersection, you'll set them equal, move everything to one side, and use the quadratic formula. So that's mechanical stuff about quadratics. Hope that helps.